Hi, good afternoon, and welcome to 24/7 Magazine's webinar, Optimize Your Infusion Test Strategy, sponsored by Fluke Biomedical. I'm Carrie Forsyth-Stevens, the editor of 24/7 Magazine and your host. I'm here with an excellent speaker, Shirin Khanna, Fluke Biomedical's Senior Marketing Manager. Ms. Khanna is a seasoned industry professional, having managed diverse product portfolios for more than 20 years. She is also a leading force behind product innovation at Fluke Biomedical, driving customer research and device design. After the presentation, Ms. Khanna will answer as many questions as she can live. So throughout the webinar, submit your infusion test-related questions via the Q&A box on your screen. Also, the complete slide deck is available for PDF download. Refer to the box on the right-hand side of your screen which says Slide Deck for Download and click on the link anytime during the webinar. Now, it is my pleasure to introduce you to today's speaker, Shirin Khanna.
Thank you very much, Carrie. Hello, everyone, and welcome to the webinar on infusion test strategy. It's my pleasure to be here today and to speak with you all about infusion testing and the solutions that are available to optimize your strategy. As Carrie said, that we will have questions at the end that we'll be happy to answer, and if there's those that we cannot get to, we will approach them individually and get back to you. So let's go ahead and get started. The agenda today will be to discuss the different infusion test methods. I'm sure that each of you has a specific method that you have used to test infusion pumps. And there are a variety of methods that are available, and we will be discussing those methods as well as the pros and cons associated with each one of them, including common errors that you should be aware of. We will then discuss things you can consider to make your infusion pump testing more effective, how you can optimize your strategy, knowing that infusion pumps are one of the highest stock devices in any medical facility. We will talk about what you can do to speed up testing as well as make sure that you are error-proofing it in any way possible. And finally, we'll go over some of the solutions that are available for infusion pump testing that you may want to consider as you think about optimizing the strategy. So let's talk about the different infusion pump methods. I've been to a lot of hospitals and spoken with many of the biomedical professionals, both here and around the world. Now, infusion pumps are a great number of devices that you have to perform preventative maintenance on each year. In fact, it's one of the highest stock medical devices I just mentioned. Accurate analysis of infusion pumps is critical. We know that for patient care. FDA had issued some guidance several years ago. We haven't really seen many updates since then, but it's still startling that, in a period of 4 years that they tracked, there were 56,000 adverse events and over 500 deaths, including 87 recalls associated with infusion pumps. And so, needless to say, it is so critical for us to make sure that these devices are operating optimally, because incorrect readings from a poorly performing pump can put a patient at great health risk. And we all strive every day to make sure that patients are safe, that all the operators are safe. So it's very, very important to test those pumps per the guidelines issued by the manufacturer or by your organization, whichever method you use. So what is required to be tested when it comes to infusion pumps? The first thing you test is the physical condition, the device itself, the filters. Are the vents clean? Is there any physical damage to the instrument? What about the inlets and hoses? So all the physical characteristics of the pump have to be evaluated to ensure that they are in good condition. That is then followed by electrical safety testing. And the electrical safety testing is to ensure that there is absolutely no risk to the patient in terms of leakage current, and the device is electrically sound. As you know, with patients, the immunity is usually lower, so they are more susceptible to currents that a normal person can maybe absorb. Because of that high sensitivity, there are electrical safety standards depending upon which country you're testing in that ensure that you are taking those measurements and making sure that your device, your medical device, is sound. And that also applies to infusion pumps. So generally, for infusion pumps, we test the line voltage, we test ground wire resistance, we test chassis leakage, and there are a number of other parameters that are tested as well to ensure that there is no leakage current, and electrical safety analyzers are available in different forms, shapes, sizes, depending upon your needs. If you're just looking for an electrical safety analyzer that tests infusion pumps, a simple device that doesn't have applied part testing would be adequate, or up to 5 applied parts would also be good in order to test an infusion pump for electrical integrity. The next thing is preventative maintenance. You want to make sure that the flow detector is clean. You want to verify that the unit will operate on battery correctly. There's so many times, so many instances we hear that biomeds are called to the floor because the pump is not working, and it's the battery that's to blame. It's either been discharged completely or it wasn't replaced based on the interval it was supposed to be replaced on. So batteries tend to be a big headache. We recognize that. And then, of course, there's complete model-specific preventative maintenance that a manufacturer will issue in terms of the other steps you need to take. This is a little bit different because in the next section, usually in a service manual, is performance testing. So performance testing now gets specifically into the things you need to measure as far as the performance of the infusion pump goes. So here we're talking about the flow and volume accuracy. Is the pump actually putting out the volume that it's supposed to over a duration of time specified? Is the flow accurate? Is it delivering the volume at the correct flow? Is the infusion complete or KVO parameters good? Is the occlusion detection pressure correct? So each pump is supposed to issue an alarm if there is occlusion pressure or if there's occlusion at the patient side. Is that alarm going off at the right PSI? So these are the things that you need to verify, including alarm function and some of the other parameters. Generally, when we talk about infusion pump testing, electrical safety, preventive maintenance, and visual inspection are in one bucket, and the performance testing, which is flow, volume, that's something that is more rigorous. And also, this is where a lot of the errors also come into place. You have to be very careful because that's where a lot of the malfunctions happen in infusion pumps. And finally, documentation. So you want to make sure that you are documenting the work that is done per the regulations of your organization. In some countries, this is based on the regulatory environment and how you're required to test infusion pumps. And in other countries, it's not regulated. The organization decides whether they will create their own procedure for infusion pump testing or whether they will follow the manufacturer's recommended procedure for the infusion pump make and models that they have. Generally, we see that most organizations go with the OEM service recommendation on what should be tested for infusion pumps. But when you're documenting, compliance is one thing. You want to document what you did, but you also want to make sure that you're documenting in a way that ensures that you're minimizing any potential for error. And there's error related to human errors, which is documenting, or did you really perform all the tests that were required or not? And then finally, data archival, which is, are you able to access those records when you need them in a legible manner? So again, I'd like to stress there's many times I've been to hospitals where they'll pull the record, but you can't tell whether the test was done as required because either it's not legible or they can't find the file if it's manually archived. So these are just some of the things that need to be done. So when you're considering your infusion pump strategy, these are the 5 things that you absolutely have to make sure you can optimize on. Generally, in terms of infusion pump verification procedures, they're recommended once a year. So we find that a lot of the biomedical professionals around the world are testing infusion pumps at least once a year, if not more. So with that, let's get into the specifics of the methods that are available to test the performance characteristics. The rest of the presentation is going to really focus on the performance characteristics as well as how you can speed up the testing and make it error-free. So there are 3 ways that professionals test for flow and volume accuracy. The first is a very basic method, which is a graduated burette with a stopwatch. You're essentially using this type of measurement to calculate flow. So it's volume over time, which is pretty simple. The other one is using a beaker and balance. Many manufacturers recommend this as well. Now, I've been asked this question many times. If a beaker and balance is recommended, can other methods be used? They can absolutely be used because when a manufacturer recommends a method, that is something that they may have used with gravimetric scales, which are very, very highly accurate test systems to ensure the flow accuracy of their devices. But that doesn't mean that you have to use that method. It's not a requirement. It's a recommendation based on how they test. But many biomeds use the basic method, which is graduated Burette, or the next one that I'm going to talk about, which is an electronic device. What an electronic device does is, based on different types of technology, calculates the flow measurement for you. So, for example, some have graduated Burettes in the device itself that will track the fluid and tell you what the flow rate is with a very high level of accuracy. Some use bubble technology and so on and so forth. But the nice thing about these electronic analyzers is that they're really managing the risk for you in terms of error. So with any OEM's recommendation, you should be able to use any three of these methods, unless the OEM manual says you must use this, or this is a requirement for accuracy. You should be able to use anything. Let's talk about some of the pros and cons related to the graduated Burette. This is, of course, a very simple and cheap method to be used. There's no learning curve here. It's very easy to do. It's very affordable. But there's some things you need to be very careful about. There is an error potential here because you're actually looking at, essentially a manual method. Which tends to be prone to error. There's human error, as well as there's going to be residual volume in the tube from which you pour the fluid into the graduated Burette itself. You're still going to need other measurement devices to complete the PM. Will have to be careful on when you are measuring what level are you measuring on the meniscus or the top level. And also, it's going to take you longer to do the measurement with the graduated Burette. You're going to tie a user down to really watch the entire flow process go through, and then manually write down what happened, and then do the calculations. So it's cheaper, but it has potential for error that you need to be mindful of. Same is true for the Beaker Balance method as well. It's very easy to set up. It requires minimal training. It's reasonably accurate, but most scales, by the way, where in this case you're actually measuring the weight of the fluid, are really rated for repeatability, not accuracy. So be careful when you do that. And those repeatability ratings are, depending upon the type of scale you have, could be 10 to 20%, as high as that. So depending upon what the requirements are for accuracy for you, when you're selecting the scale, always be careful to note exactly what the accuracy of that scale is, not the repeatability. Some other issues you want to be careful about is there's going to be residual volume when you pour the liquid out. It is prone to human error. Again, you're tying down a user specifically to this measurement. So you are also, again, going to need other gadgets to complete the PM. So when I say other gadgets, what I mean is, you're usually doing flow and volume that you can do with either the Burette or the Beaker method, but you also have to do occlusion. So it's a series of events that you actually have to go through manually in order to complete that performance characteristic, because you'll have to, again, dial up the pressure gauge and find out what the occlusion, at what level the pump is alarming, and whether that ties to the published spec or not. But in both these methods, again, you'll tend to take a little bit longer, and there's a higher potential for error versus an electronic analyzer. So in terms of an electronic analyzer, the nice thing about it is you get an immediate issue recognition, because you're looking at a screen, and as the pump is outputting the fluid, you can see right away if there are any spikes or issues related to that, something that you cannot do with the manual methods. You're also reducing human error here because you're not doing any calculations. Everything is done for you. Essentially, you are hooking up the pump to the analyzer, and watching what happens in terms of the flow measurement. Once you turn the pump on, depending upon the flow rate that is programmed into the pump, you're going to see whether the analyzer is showing the same flow rate or not. And so that tells you whether the pump is performing per spec or not. And then finally, you're really standardizing work and increasing your productivity because you're reducing the total test time. The other big benefit of certain analyzers, those that let you do it, is that you can test multiple pumps at the same time. So given that infusion pumps are the highest stocked items, the fact that you can now test 4 pumps in the same amount of time is going to really help you save a lot of time. And in many cases where I've been to medical facilities, I've seen that they've actually created a desk, a bench, which is specifically for infusion testing. And there's, essentially deionized water bags that are connected to pumps, and they're just going through it so quickly. It's very, very impressive. Later on in the presentation, we'll get into what that means in terms of how much money you can save or how much time you can save, but that's something to consider when you're trying to decide which method you're going to go toward to test infusion pumps. Now, there is, with an analyzer, there is a slight learning curve because most of these are very, very easy to use. But if you're going to get into complexities of trend analysis and data analysis, there'll be a little bit more of learning. But, the returns you get in terms of time later on and in terms of accuracy outweigh the cons related to an analyzer. The next thing is testing pressure. So the methods to test pressure there are also several methods here. You can use a basic analog pressure gauge to test pressure. You can use a digital pressure meter to do the same thing, or you can rely on the analyzer itself. So instead of taking a manual measurement with a burette and a beaker and then using a pressure gauge, if you had an analyzer, most of the time it should be able to do both of those for you. Strengths and weaknesses of using the different methods in terms of the analog gauge versus the digital pressure meter are that the gauges are very accurate. We know that. They also have a short learning curve. They're fairly easy to use. But in terms of cons, again, you are working with something that's not typically automatable. It requires the operator to be dedicated to the testing. And you're limiting this to one test at a time. So I'm not sure if that is the best strategy. Bear with us one second here. The next thing is the electronic infusion device analyzer. If you're using that versus the pressure gauge, again, you are essentially starting the pump and it's going to tell you what the occlusion pressure is. So you don't really have to do anything there. You're essentially having the analyzer do all the work. So once you start the pump, it'll build a pressure and it'll actually alarm, and the analyzer will tell you whether the pressure reading on the analyzer is the same as the manufacturer's spec. So again, you're taking the variability and any errors related to that out of the equation. Now let's talk about the different steps that you can use to optimize your strategy. We've talked about the different test methods and the pros and cons of each one of the methods when it comes to performance characteristics. We're going to get into now when you're thinking about how you can, no matter what method you use today, when you are thinking of improving upon that, what are the things to consider? The number one thing you need to consider is risk. What are the risks associated and how you can minimize them? Second is compliance. Are the methods that you're using today, are you sure that they are absolutely 100% compliant to the process that you have for your organization, whether it's to test to OEM manuals or something you've defined for your own self? And the third is cost. In terms of strategy, is there any way you can make this process more efficient for you? And cost is time, right? In this case, we're talking about how we can free up more time for biomedical professionals to do other work that they need to do and minimize the amount of time that they have to spend testing infusion pumps. So let's talk about risk. Now, this is essentially an excerpt from a quality assurance book that Fluke Biomedical publishes. It's called the MDQA. and you're welcome to get a copy of that through Fluke Biomedical. But we essentially go through all medical devices, and based on characteristics such as clinical function and other parameters, there's a rating given to each medical device, which shows you at the end what your risk factor is. What's the total risk for this particular medical device? So if you don't already have that, a lot of organizations have that already for their for the medical devices that are tested. But if you don't, then you're welcome to use our guide to assess how critical it is to test an infusion device. So that's the first thing, is you need to do the risk assessment for each one of the medical devices that you have or that you work with to understand what is the risk associated with each one of these devices. The second thing is compliance. Now, compliance essentially comes down to one simple thing. Are you doing everything required or not? And of course, everyone's striving to be compliant here. So the work needs to be done. Some of the things to consider in terms of compliance is to automate the work. When you automate the work, what you're really doing is not just speeding up the testing time, you're reducing human error or the potential of it by standardizing the work. So when you automate a preventative maintenance procedure, and let's say there is a software program that is guiding you through every single step that is required from start to finish on preventive maintenance on your infusion pump, you are ensuring that no matter who does the preventative maintenance on that pump, the same work is going to be done every single time in the order, and the data will be archived as specified. And that is really powerful because that also brings your risk factor down tremendously and ensures that everything is done per the requirements of your organization or any regulatory bodies if they're involved. So please consider automation because it is very, very powerful. It brings in efficiency. It reduces cost for you, and for those that are into analytics and want to do trend analysis, you can take all that data and really look at how good a certain pump or a certain model of pump has been for your organization. We have a lot of users that take a lot of the data that comes out of the trend, and they do trend analysis over a period of 5 or 10 years to really make decisions on which infusion pumps are best for their organization or for their work. So that is a little bit more evolved, but generally speaking, test automation has a lot of immediate, very powerful benefits, specifically in terms of work standardization to make sure that all the work is done as required, and essentially time management to make sure that you're reducing your total test time. And of course, most of the test automation output can also be archived electronically and all or be stored to, as a PDF with your CMS work order. So that way you have the test records in an electronic form where they need to be right off the bat, and you're not really spending time scanning results or writing them down and then putting them in a system. So those are also additional benefits of having test automation as far as testing infusion pumps go. And then I had mentioned this earlier, but, why would you test one infusion pump at a time when you can test 4? In this case, you really have the opportunity to maximize your productivity and complete your preventative maintenance procedure on time. So we actually have a really wonderful white paper that was written by a super user in Japan. And this individual is very well respected and has written about efficiency gains that his organization realized by testing simultaneously. And of course, he went ahead and he tested, he was testing up to 24 pumps at the same time. But generally what we see is the bench setup that I described earlier. We have seen multiple organizations essentially churn those pumps very, very quickly, because once you have the pumps, the basic layout in place, you're basically doing flow measurement and occlusion measurement very, very swiftly by testing simultaneously. So, and that should not slow you down at all. Once your setup is complete, it's almost like an assembly line where you're putting pumps through the preventative maintenance procedure fairly quickly. And finally, it doesn't stop with the efficiency savings or the time savings. When you actually look at the cost savings, they're phenomenal. There is a model here, and you can also find one on our website that'll show you exactly how much money you can save depending upon the number of beds that you have in your hospital and the number of infusion pumps that you are servicing per year. So in this particular case, we used a hospital with 350 beds that was able to realize almost $10,000 in annual savings. This is just in terms of savings related to using an electronic analyzer for testing infusion pumps. And the savings come from two places. One is you're reducing your total test time. And when you equate that to what that means in terms of, how much time you're freeing up for your biomeds, that's one piece of it. And the second piece of it is the documentation, all the time that you're saving in documentation and not writing things down physically. You add those two and you basically get your total savings. And, if this is a 350-bed hospital or if you have more pumps than shown here on this particular model, you're going to save more. So we're always happy to help customize this for you. You can contact us at Fluke Biomedical and we can do a custom analysis for you, or you can use our web tool to see what this would mean. So with that, let's talk about some of the products that we have. As you know, Fluke Biomedical has been a provider of infusion device analyzers for over 25 years, over which we've demonstrated accuracy and reliability. And we're proud that we have thousands of biomedical professionals globally that trust us implicitly when it comes to infusion pump testing. The technology that our device analyzers have are on the flow measurement side. We have a miniature burette with infrared sensors along its length. And the sophisticated electronics basically track the flow and will give you the flow rate in terms of what the analyzer is observing immediately. As far as pressure measurement goes, we measure back pressure during flow tests as well as measure occlusion pressure. And this is done by operating the solenoid valve to block the flow of water. And once the pump alarms, you can see immediately what the occlusion pressure is and have a fairly quick reading of that parameter as well. We have two products that we sell for infusion device analyzers. The first one is the IDA-1S. This is a small on-the-go infusion device tester that we introduced a few years ago. It's become increasingly popular. It is very popular and known for its portability. It's about 2.5 pounds, so fairly light. The emphasis here was to create a tester that you could take with you on the go. We recognize a lot of the biomedical professionals are on the go a lot of the time, and depending upon where you are, you may not have the luxury of carrying a multiple device analyzer with you. So we created the IDA-1S. It's our on-the-go tester. It has a carrying handle. It is battery powered, so you don't have to worry about plugging it in if you're in a location that doesn't allow you to do that easily. It also has a touch screen for simple operation. It can test one channel at a time. It also features onboard memory, so you can store results instantly. And it comes with complementary software. It's called Hydrograph. The Hydrograph software will allow you to operate this unit remotely and to store the data. So if you want to do trending and analysis, you can do that. All of those options are available to you. So the IDA-1S has a flow rate of up to 1,000 milliliters per hour. It has a volume measurement of 999, and it tests occlusion pressure up to 45 psi, which is also available in other units as shown here. And the second product line we have is the IDA-5. Now, IDA-5 is also an electronic device analyzer. It tests up to 4 infusion pumps. It is a fairly comprehensive analyzer. It has built-in automatic testing, which means you can actually program templates on the device itself and hit start, and all of that is then documented as you step through the procedure. It has plug-and-play data entry as well as printing, and what this basically means is there are no custom accessories. You can hook up a keyboard to it or a printer to it, print the data right away. So it's up to you what you want to use in terms of accessories. It also has a very high flow rate capacity, up to 1,600 milliliters per hour. It complies to the 60601 standard for infusion pump testing. It can test up to 4 pumps together. And if you use this with our automation software, you can test more than that. We'll get into that a little bit later. And it's upgradable. What that means is that the IDA5 you can either buy in a configuration that allows you to test 1 channel, 2 channels, or 4 channels. And what you can do is if you're not sure and if you want to start out with testing 2 pumps at once, you can send it to us for an upgrade, and we will add an additional channel for you depending upon your requirements, or 2, whatever you need to do. So it has the capability of adding more channels later. It is also the lightest 4-channel solution on the market. It weighs close to 7.5 pounds. So it looks pretty big, but we've made some improvements to it over the last 12 months since its introduction, and nearly cut the weight in half. So we've made it so that you can easily carry this one as well. The footprint is still as it was originally, but the weight is much lighter. So it's a pretty fast analyzer. As I'd mentioned, the auto sequences can be customized per your needs. You see a real-time snapshot of flow and pressure, and that's the beauty of it. So you don't really have to look at data. If you have the screen on graphical format, you can see right away what's happening with the flow characteristics of the infusion pump. And if you're doing testing over a period of time, which many of you do, this is very powerful to see spikes and issues related to an infusion pump. It also has simultaneous testing. As I mentioned, you can test up to 4 pumps at the same time. And with the keyboard option, you can enter data either through a keyboard or a barcode scanner fairly easily into the analyzer itself. Also, this product has been proven over 25 years for its accuracy. So, we really stand behind all the specifications for our products. It's a highly accurate infusion device analyzer. It was built to make sure that you can standardize testing very, very easily if you do not want to use, automation beyond the tester itself, and you want integrated automation that is available. So essentially, the IDA5 will ensure that you are reducing your error through the standardized testing, as well as you're managing flow and measurement as needed and as specified. So it's very powerful in terms of its capabilities. It's got some very comprehensive features. It can also test any brand of infusion device and any kind of infusion device. So no matter what the OEM service manuals say, you are free to select the method you're going to use to test infusion pumps. You may be required to enter data that you're reading off the infusion analyzer, but you should be free to select any method unless the OEM says you must use the specific method and no other. So please always keep that in mind, because that has caused a lot of confusion over the past years as to whether analyzers can be used with certain brands of infusion pumps. This is a quick snapshot of how you can automate the IDA5. So what you're seeing here is a template that had been programmed into the device. You basically hit start. It immediately shows you the average flow. The infusion pump is obviously operating at this point in time. And you can specify whether you want the flow to end on volume or on time. And once that's done, you move on to the next parameter, which could be another flow reading or occlusion pressure. And at the end of it, you have the ability to print the results right away, save and print them, just print them, or essentially, delete them from memory. So these options are available to you with the automation that is built into the IDA5. And let me just reiterate, this doesn't require you purchase any software. This is integrated automation into the device itself. It's, like I said, designed for comprehensive testing. So the unit will actually show you up to 2,600 milliliters per hour, but we only specify it up to 1,500 milliliters per hour as far as testing goes. The volume measurement is up to 9,999 milliliters. It also has dual flow as well as PCA bolus measurement, and the pressure measurement is up to 45 psi. It also has an auto start mode, and the auto start mode is actually makes the infusion device analyzer even more accurate because it will only start testing once it detects flow at the inlet. So let's say you push start on the infusion pump and then you push start on the infusion device analyzer, or vice versa. The only time it's going to start the measurement is when it detects the fluid. So it makes sure that every single drop is being counted when it's giving you the reading for the flow measurement. Here's a quick comparison chart for those of you that are familiar with our legacy IDA4 Plus analyzer. This shows you the differences between the IDA5, the IDA4, and the IDA1. So essentially with the IDA5, we've added built-in automatic testing, expanded the flow rate specification. It has a priming indicator, so it'll show you graphically very quickly when the priming is complete. It gives you the ability to end the test on time or volume. Has the ability for you to plug accessories such as keyboard or scanners that are USB-based, that are not custom accessories. It also has the ability to print, as mentioned earlier. Both the IDA1 and the IDA5 have an onboard manual that you can access at any time. And the IDA5 is also compatible with our Answer automation software. And Answer basically is automation software that allows you to combine the other four parameters that I had mentioned along with the performance characteristics. So what Answer software does is it'll take your preventative maintenance procedure that you have today and create an exact electronic replica of it. And when you run the software from the first step to the end, you're actually going through the stepwise procedure, including physical inspection, electrical safety analysis, and all performance characteristics stepwise as required. At the end of it, Answer will give you a report that you can store in the software format that we have, which is by default the Answer format, or in a PDF format that you can then attach to your CMMS work order. So if you're interested in integrated testing where you want to bring everything together and maximize your efficiency, I would highly recommend you look at the Answer software, because it allows you to essentially create an electronic replica of your preventative maintenance record, and that really helps mitigate risk as well as reduce error, which in the end is essentially providing a lot of benefits along with time savings for you. Okay, so that's a quick snapshot. Of course, we have a lot more information that is available to you on our website, but I just want to stress that at Fluke Biomedical, we design products with reliability, safety, and efficiency in mind. Our goal is really to give you the confidence to test, because along with you, our goal is patient safety as well. So if you have questions, please feel free to reach to us. There's a lot of different options available. You can reach us through our website, or you can call us. We also have a ton of information available, such as white papers. There are product videos. We have an advanced training center that you can visit that has a lot of information, not just about infusion pump testing, but a lot of other medical devices. There are quizzes you number of social media platforms of your choice. So that is available to you as well. That concludes the presentation. If you have questions, in-depth questions, feedback, please go ahead and send them to us now. We'll be taking questions. I'm going to turn it over to Carrie for some of the questions that have come through while I was presenting.
Okay, great. Thanks, Shirin. My first question, can you tell me a little bit more about automation with these products?
Yes. So as I had mentioned, and this can be a little bit confusing, there are two ways to automate the product. You can either go with the integrated automation in the product. So as I had mentioned, the IDA5 has the ability to create a template for performance characteristics. So that's flow, volume, occlusion measurement. And that basically, based on the number of different brands and models you've got, you can go ahead and essentially automate it on the device itself, not use any other software, or you can go ahead and get software like Answer, like I just mentioned, which is a plugin. It's essentially a software program you buy, and that automates the IDA5. So once you start the Answer procedure, it'll walk you through the physical inspection steps, yes, no, or whatever else you need to enter. It'll then hook up to one of our electrical safety analyzers and automate all of the electrical safety for you. All you'll have to do is the setup. So you're basically moving the leads from one point to the other at one point of testing, but other than for chassis leakage. But other than that, it'll automatically get the parameters for you and put that all in the Answer report for you. And then it'll move on to infusion pump testing and do the flow measurement, do the occlusion pressure measurement. And at the end of it, you're essentially getting a report with who did the testing, when it was done, and what the data is. So that's the software piece of it. And the first piece is the integrated automation in the analyzer, where you essentially just get the readings and who performed the test, but those are only related to flow and occlusion. So the difference between software and integrated testing is performance only with integrated testing, and performance plus electrical safety plus visual inspection plus anything else you need to add with the Answer software.
Great, thanks. And do these products work with Alaris pumps?
Yes, they do. In fact, when I mentioned earlier the different methods available to you when you're free to test, one of the examples is Alaris. In fact, there's a lot of, and also known as CareFusion now, there are a lot of hospitals that have Alaris and CareFusion pumps that are actually using the IDA5 analyzer. The confusion comes from the fact that Alaris has software that they provide, and you're basically walking through the software, entering all the information. They allow, I believe that some of their pumps have the Beaker method that is recommended. Essentially what you're doing with the Beaker method is you are, again, calculating what the volume is with the Beaker method. Yeah, you can do with the IDA5 as well. So whatever it is that you get from the Beaker method, you get it from the IDA5. You have to input that anyways. So using 1 milliliter equals 1 gram of water, that's the calculation that our users use to input the grams required for Alaris pumps. So you can absolutely use the IDA5 to test Alaris CareFusion pumps. Many of our end users do it very successfully and are pretty happy with that.
Wonderful. And my service manual recommends a Beaker and scaled method for volume measurement. Can I still use your product?
Yes, as I just said, this is also along the same lines. You can absolutely use our product. No matter what method you use, at the end of the day, you are looking for a reliable method to come up with the flow measurement of the infusion pump, whether it's flow rate or volume. So any of the methods described can be used, and the electronic analyzer method tends to be the most accurate.
Great. I think this is a great one too. This is from a reader. Must deionized water be used for all testing, or would that be specific to the electronic analyzer or pump?
We recommend deionized water for our pumps, and the reason for that is, and it's actually, we also recommend you add a little bit of detergent that is provided with the product. It's a very low concentration because it keeps the internals of the analyzer in a method so that the surface tension is reduced to optimize accuracy. But deionized water is the best method to be used no matter what you're using. I know a lot of individuals use distilled water with Beaker and Burette. And again, in the Beaker method, it may not matter as much, but for the Burette as well, if you want to reduce the surface tension, use deionized water, and maybe you want to add the detergent to that as well. But generally speaking, go with the method that is recommended with whatever device that you have. Most of the time, manufacturers will tell you what the best method is, whether you should be using deionized water or distilled water. Specifically in the case of...
Great. I know you kind of spoke on this before, but would the Beaker Balance test be the most favorable routine?
Well, we went through the pros and cons. So the Beaker Balance, in my opinion, is prone to errors. So I would always recommend an electronic analyzer because that makes sure that you have optimized your accuracy and you've minimized your risk. So I would always recommend that over the Beaker Balance method, unless, of course, you're using gravimetric scales, and then those are $30,000 to $40,000 each, which you don't see in the biomedical test arena. That's usually used by OEMs. So, when you're testing infusion pumps for preventive maintenance, I would go with the electronic analyzer.
Great. And what are your suggestions for testing the smart pumps, which are integrated with the clinical information systems, especially checking their bidirectional communication?
So at this point in time, we don't have a recommendation for smart pumps in terms of bidirectional communication. The only pumps that we say you can test are the ones that require the volume and occlusion measurement. So whichever pump that you have, whether it's smart pump or not, at this point in time, bidirectional communication is not available, at least not through our solutions.
Great. And is there anything else you want readers to know or listeners to know that we haven't spoken on already?
Not that I can think of.
Okay. Okay. Well, we have a final reader question.
Carrie, I did see a question that came up here that I'm going to go ahead and ask. Are there plans to make the reports into a PDF form? Yes. Printing on paper requires us to scan it before we can add it to our database, and a PDF would be much easier. Yes, absolutely. So with our analyzers, if you use integrated automation in the IDA5 and you want to print out of it, you can get the data in PDF form. We have free software that you can download from our website that allows you to port all of the test sequences, and essentially you then have the ability to either PDF it or use it in a .csv format, or just use our program itself. But either way, to answer your question, you should be able to get a PDF copy very easily with integrated automation. And of course, if you're using Answer software, all the Answer reports can be turned into PDFs quite quickly and easily.
Excellent, and thank you so much. I want to conclude by saying thank you to our presenter, who did a wonderful job, as well as our audience members and our sponsor, Fluke Biomedical. Today's webinar is being recorded, so you may rewatch for free anytime in the next year using the same link you've used to log on today. And feel free to share the link with colleagues who may have missed today's live event. Also, please email me at kstevens, and that's Stevens with a PH at Medcore, and that's medqor.com, with questions, comments, and future webinar suggestions. And also, please be sure to visit us at www.24mag.com. Thank you again for participating in 24/7 Magazine's webinar. Optimize your infusion test strategy. Have a wonderful day.